You listening to Trigger Seattle podcast.
On November 14, 2020, T-Mobile and Drone Racing League announced multi-year partnership to innovate 5G technology to Reimagine sports entertainment. DRL will develop first-of-the-kind custom racing drones powered by T-Mobile 5G in 2021 DRL Alliance World Championship. Vadim, I have a question for you. Where are we going with this technology?
5G is not about data only, huge amounts of data that we can download. Yes, it is number one thing. But the other very important thing that allows a lot of use cases like this is the latency. The 5G latency is lower than 4G, right? So now this is very important to remember. And that's a good use case, right? So drones, right? Racing drones going around, 100 miles per hour?
Yeah, those
right?
pilots must be insane, to control drones 100 miles per hour in those 3D dimensions. It's crazy.
Right. So, but we've been driving. You can, if you go crazy about a speed limit, you can drive 100 miles an hour in your car. But you're only doing a phone call, right? We've done it. It's old technology. But here, like you said, it's 3D. In 3D space, your drone is moving, changing directions, and it's very fast, right? So, and you're operating it. You're not sitting on the drone itself. You're somewhere, and that's where the latency. It's very important subject here is the latency. That's perfect use case reflecting how 5G is powerful with the low latency numbers.
Pilots, they transfer data, video data from drone itself, live feed, and viewers, 10 millions of future fans are gonna go to those networks like Facebook, NBC, and see those drone competitions. Let's watch the video. Let's show the video. I think this is crazy technology. You have to be insane to fly this drone, and those pilots.
Typical human reaction time is 200 to 250 milliseconds. It's between when you see something, then from that moment to the moment when you can react to it. Is press the button or do something about it, right? Human eye reaction time is 15. 20 milliseconds. It's where, these monitors, you buy a monitor, the gaming monitors, they have really, really high refresh rate. So you see the picture changing very faster, updating the
That's
refresh.
very interesting.
So in this case, they are basically racing and you have several channels, right? You were saying, hey, so there's a channel that transmits the video, and there is a channel where the drone pilot wearing these goggles is actually seeing what the drone is seeing because he's piloting it, right?
Yeah.
And he has to have very low latency for that, because otherwise, you can imagine, it's very easy calculation. I think it's if you have network latency of maybe 50 milliseconds, you add on top. By that time, 2 milliseconds is before you actually see the event, right? So it translates to something at these speeds, 100 miles per hour. It's 6 feet. So if you're going through the gates on the course in this drone, you can actually crash it because you don't see what's actually drone is flying. So you see 6 feet in the past for the drone because of the network latency. So the latency is very important.
They probably know the way where they're flying, right?
They predict.
Predict?
Yeah, they anticipate. They train, I'm guessing, because they know only 6 feet behind. 5G latency is smaller than that. Hopefully with that low latency, they will be, pushing that to less distance, and they need to predict less. There is also a control channel where you're actually piloting. It has the delay too, your joystick or whatever they're using. Right, it has a delay, but when you press the button, the drone changes direction with a certain delay.
5G technology allows, in the peak moments, to translate 1 gigabit per second. That's a huge speed too, as well. It's huge.
Yeah, now it's more. It's more than that.
It's even more than that?
Oh yeah. a good
I mean,
radio environment.
do we really need more? Because, like, yes,
Good question. Do we really? I think we need to get as much as we can. I think, like, I believe, and then we'll. It's like, remember the same story with microprocessors, right? Do we really need all these, gigahertz of FPS? Yes, we will need, because we'll find this use case in the near future, right? If we don't have that, then we don't have the use case, right? Same thing with, as you can see, 4G was there, drones were there, but the use case was not there because they had latency and they didn't have enough data. They didn't have enough bandwidth, I guess, and they didn't have enough speed at that time. And now with these drones flying 100 miles per hour, sending 4K video, it's a huge amount of data with something which is very mobile. It's very mobile. Our other applications of 5G, right, like AR, VR, and that's where the latency and data speeds are coming into play, creating or supporting this use case. Even like there's a video of actually somebody performing remote surgery on the banana, right? Like, it just tells you, like, now we're at the gate where we can actually start thinking about that. Telemedicine, they call it, right? And I think he was using dedicated channel or like, maybe like 5G access point on both ends. So he would create like, end-to-end robust latency, low latency channel, because he has to see the scalpel moves. Should be like in a millisecond. The view of his screen or whatever he's watching at, or like maybe his AR glasses, VR glasses, has to be in the milliseconds, not more than 10 milliseconds, because otherwise you'll be like, because of the lag, you will be making wrong incisions. It's pretty cool. It's just like autonomous vehicles, right? Same thing, a low latency. It allows the car to react quickly to the road conditions, to the traffic, to the accidents, to anything like this. With high latency, you're reacting too late. Right?
Yeah, that's true. Yeah, like I see now used like in the robotic industry, in military technology become available, so which becomes to generate more robots, more advanced future machines can be help maybe our society.
Agriculture, remote agriculture is another, I think, hot topic where, you can actually have autonomous farming without like human participation or like minimal human participation. That's maybe a very good topic for some of the areas where we don't have like good crops, or like we have famine or something like that. We're just like thinking out loud right now, but
that's very interesting.
It is reality. I mean, teleconferencing, like with the pandemic, right? So everybody's on the video calls. Everybody's like, it's interesting how the actual use cases come our way without even us like putting them out there.
Yeah, that's very interesting. Yeah. Thank you, Vadim. Thank you so much for open up this big conversation, and it was like fun talking to you.
Thanks, Oleg. Thanks for inviting me.
Thank you.
Yeah.